Quartz veins are natural deposits of minerals that are really important and have produced a huge amount of gold and silver and other minerals, and they're just really interesting and potentially very valuable. So today we're going to talk about, well, just what is a quartz vein? How do they form? How to evaluate them to see whether they're rich in mineral or not? Because not all of them are, but they're pretty common, and we're going to talk about them and how they form and even how to work them a little bit. And so this is going to be a great video. I hope you stay tuned because you're going to like it. Now, the quartz is a natural compound of the two most common elements in the Earth's crust. So the most common element in the crust, the top few miles of the Earth, is actually oxygen. And it combines with the second most common element in the Earth's crust, and that's silicon. And when you put the two of those together, silicon and oxygen, you get quartz. They form most commonly in various fractures and fault zones where the solid rock has opened up a little bit and there's room for minerals to be deposited. Now, a lot of you guys probably have never seen a quartz vein in the wild, or maybe some of you have, but it'd be interested to see more. So let's take a look at some examples of what quartz veins look like in the natural wild, in their natural environment that you might run across if you were out in the field prospecting and exploring.
Here's a little quartz vein outcrop in the desert in Nevada, and you can see it doesn't stick up much, just a little tiny bit above the ground surface, but there's a scattered quartz float that's going down from the vein outcrop itself. Here's a quartz vein that's located in the Sierra Nevada gold country, and it sticks out a foot or two above the ground and is pretty obvious. This wouldn't be easy to miss. Quartz veins come in virtually all sizes. This thing, as you can see, sticks out many feet above the ground, but it's also more than 20 feet wide. It's 20 to 30 feet wide in places, and so there's really a lot of quartz here, and in places it was really rich, but in most places it was barren. But like I say, there were some rich pockets taken out of this vein. Here's a quartz vein in the Sierras where the area was smoothed over by glaciers. Basically, it ripped off the surface soil, and you just have the solid rock with the vein, where you can see it just occupies a fracture, a zone in the existing country rock. Although it's still a natural quartz outcrop where you can see the white quartz, this is an outcrop, of course, in the desert of Arizona, and it's a lot more bleak. And actually, when you get to see a quartz vein like this, and if you're in a desert area, a lot of times it's much more easily traced over a long distance. Here's a quartz vein outcrop in Nevada, but it's a little bit different. The surrounding rock surrounding the quartz vein was a volcanic rock, but it's so deeply weathered, the surrounding rock is basically converted to clay and soil. And yet the quartz, because it doesn't weather like that, because it resists weathering, you can see the vein in place, but it looks as if it was surrounded by clay. But really, this was originally a volcanic rock that this vein formed in. Here's a quartz vein outcrop in Western Australia. The point of this is to show you that in different environments, quartz vein outcrops can look wildly different, depending on where they are, the type of rock that they're set in, or how weathered the rock surrounding them is, or whether there's a lot of soil, determines whether you can see the vein over a long distance or not. And just there's a lot of variables when it comes to recognizing quartz outcrops.
Now, one of the things about quartz veins is because they're made up of the two most common elements in the Earth's crust, they're fairly common. And although usually if you find gold, you'll find quartz with it, but it doesn't work the other way around. That if you find quartz, you're going to find gold. If you find gold, you're going to find quartz. But if you find quartz, may or may not find gold. Because it works because quartz is super common. I mean, literally, quartz is probably the most common mineral in the Earth's surface, because there are whole kinds of rocks made of pretty much nothing but quartz. Sandstone is mostly nothing but quartz. And then quartzite, which actually forms, is metamorphosed sandstone. In other words, sandstone that's been subject to heat and pressure, you get quartzite. And quartzite, just by its name, you can tell it's made of mostly quartz. So these are two very common kinds of rocks that are made of mostly quartz. There's a lot of different types of rocks, like granite, that have a significant percentage of quartz in them. And so quartz is a fairly common mineral. And so a common mineral, but gold, is really rare. And that's why when you find gold, you almost always or very frequently find quartz with it. But if you find quartz, you're not necessarily going to find gold with it. In fact, honestly, there are far, far, far more barren quartz veins than there are veins with significant gold in them. Let me show you some examples of rich gold quartz, and we'll talk about gold in quartz and what that looks like and how it forms and that kind of stuff. Let's take a look at some examples.
When we think of rich specimens of gold in quartz, we think of stuff that's like this. This is just a little tiny, like little more than a ½ inch wide vein, but it's just stuffed full of gold. And of course, it wouldn't take a lot of this to be worth a huge amount of money. And super rich specimens like this are really the goal of the prospector hunting for pockets. I mean, this is the kind of quartz that stories are made up about and, are easily found with a metal detector. And this is like 100 pounds of quartz with many pounds of gold contained in it. Now you can see the gold in this quartz, it's pretty obvious, but there's some brown and other stuff that's next to the white quartz, and you start wondering, well, what is that? And that's actually pyrite, and some of the dark brown stuff is pyrite that's been oxidized, and all of it's been oxidized at least a little bit. And that's why people tell you, look for the mineralized, rusty brown looking quartz, because a lot of times it has gold. Here's another piece of gold ore where the ore has been completely oxidized and any pyrite that's in it has been converted to iron oxide's rust. But the gold is clearly visible, the beautiful bright yellow gold in this specimen. Now you'll hear people suggest that you should always look for the mineralized, rusty colored quartz that's, like I say, very mineralized. But, that's a good rule of thumb and it's often true. But there definitely are exceptions, like this white, seemingly unmineralized piece of quartz that's just shot through with gold. But most gold ore that's mined commercially does not have gobs and gobs of visible, showy gold. It may just have a few specks. This piece has some specks in it, and if you're looking at this on a phone, you're probably not going to be able to see them. So let me show you where the gold is on this piece. And here I've circled in red what the little specks of gold are. And you might look at this fist-sized rock and say, well, this is pretty low grade. But no, this is super high grade still, because these few specks would add up if you had a ton of this rock. And when an ounce of gold in a ton of rock is excellent grade rock, it doesn't take a whole lot. A few specks is more than enough. But if you are out with your metal detector or whatever and you come across a piece like this, this is the kind of thing you want to start looking for the source, looking for where is this gold coming from. And, we're going to talk a little bit more about tracing float gold to its source in a later part of this video, but that's coming up in a few minutes.
Well, like I say, the vast majority of quartz veins have little or no gold, but they may have, it is true that even veins that are mostly barren may have spits and spots of significant gold in them. You may have a vein that's 100 feet long, and for 1 foot of that, at 10 feet deep in the ground, there may be some decent gold. But wherever you test on the vein on the surface, you're going to find not much gold. So it's an interesting thing where there's a lot of quartz that doesn't have much gold, but it can have it in spots. And even veins that are rich in gold will have rich spots and then a lot of low-grade spots. It just is a thing. Now, we've talked and I've shown you some really rich pieces. Let's talk more about typical quartz veins, because the truth is, good gold quartz ore, actually really good grade, would be considered to have 1 ounce of gold in a ton, 2,000 pounds of rock. Now, you'll think, boy, that's a really small percentage of gold if you have 1 ounce of gold in a ton of quartz rock, but that's how gold veins do. And a lot of veins are worked that have a 1/2 ounce or even a 1/4 ounce. And in big low-grade operations, big open pits and stuff, they'll work quartz and silica and other quartz types of ore with as low as a few hundredths of an ounce per ton, and still make money on it. Okay, they still make money with stuff that's 300ths or 500ths of an ounce per ton, but that requires big open pit operations. It's an operation of scale where you have huge amounts being processed at a low cost, and they're able to, because they're processing so much of it, and they don't just have a little narrow quartz vein, they'll have a big deposit of gold ore that's low grade, and sometimes they're literally removing a mountain type of the thing. At low cost, they're able to process it and make money, especially considering that the price of gold is so high right now. So, pretty low grades can be worked, but the individual operator is not going to want to work grades, hundredths of an ounce per ton. I generally tell guys that a grade of about a 1/2 ounce per ton is about what makes it worthwhile. Maybe you'll get by at 1/3 of an ounce per ton, but it's a thing where you need to have a decent amount. You're not going to be working barren veins or near barren veins and get an amount of gold out that's worth your while. And you test them by crushing and evaluating them. And we'll talk more at the end of this video about evaluating quartz veins and taking a look at them. But let me show you some examples of lower grade quartz vein ore that still is, like I say, 1 ounce per ton is considered pretty good rock. That's considered very profitable at most mines. But it's a very small percentage of the rock as a whole. So let's take a look at some lower grade examples.
Here's a bit of fairly well mineralized quartz. This probably runs 1/4 to 1/2 an ounce, but there's no visible gold in it. You could stare at this with a loop for half an hour and you wouldn't see any visible gold. But there is a little bit in it, and in theory it could be crushed and recovered, but you wouldn't be getting very much out of processing a ton of rock. Here's a stockpile of similar well mineralized quartz in Nevada, and you can see a lot of iron here, and it's certainly well mineralized, and it's low grade. It probably has similar values like 1/4 to 1/2 an ounce that the other rock I just showed you has. But it was too low in grade for the miners to haul it to a mill and then have the mill have the mill crush it for them and process it and extract the gold. So they just left it here because it wasn't economic, and here it sits to this day. And here's an example of a similar well-mineralized, low-grade quartz rock from the Mother Lode country in California. And again, this rock just wasn't rich enough to pay for the miners to crush it and extract the gold. Now, this isn't a true piece of a quartz vein per se, although there's a little quartz veinlet, the white on the far left there. This is rock that's been partly replaced by silica, by quartz. And so the rock is largely quartz, but this is low-grade ore from the Carlin type mines in Nevada, and literally hundreds of millions of tons of this type of rock have been mined and processed, producing many, many millions of ounces of gold. And this thing contains a little more than 1/10 of an ounce of gold per ton. And there's some of that Carlin ore that's richer than this, and there's some that's lower grade too. But they are able to mine this stuff in bulk, huge mines, big open pits, and process it in huge amounts and make big money from mining and processing this rock. It's this kind of rock that has made Nevada the biggest gold producer in the U.S.
Now, I mentioned that quartz veins can have a gold and silver and a lot of other minerals. There's a lot of gangue minerals. In other words, there's valuable minerals, which are usually the sulfides that might have metal values in them or other values. But there's other minerals that go along with quartz veins that are commonly found in and with quartz in the veins that don't have a lot of value, but the prospector needs to know about them. And these includes things like calcite and fluorite and barite and such things. So let me show you some examples of those minerals.
Now, from first glance, this looks like a chunk of barren vein quartz, right? But it's not. This is a chunk of calcite. And I'll admit that I've had a couple times where I've been out in various districts and looked and thought quartz, and then I looked at it a second time, and because I can tell the difference. It's the cleavage of the calcite that stands out. The quartz doesn't have that. It's also, calcite is much softer, but even without testing it, you can eyeball it and see the calcite cleavage. So this is another very common vein mineral. There's a lot of minerals, or a lot of veins that are more calcite than quartz. Now, if you came across this in the dump of an old mine deposit, you'd think maybe these are quartz crystals. But if you looked at them more closely, you'd see these don't have the same shape and form of a quartz crystal, which is very common. This is calcite again. These are calcite crystals, and you can see they can make clear crystals just like quartz does. This light green specimen is another material that comes commonly in quartz veins. This is fluorite, and it can normally be told by its square cubic crystals, although there are other crystal shapes other than cubic, but cubic is by far the most common. And so fluorite occurs in a lot of veins, including gold-bearing quartz veins. Here is another mineral that's similar to quartz, at least in first appearance, although the crystal shape is, of course, much different. And this is barite, and barite is much heavier than quartz. This is a mineral that's dense enough that a lot of times if you're sluicing gravels that have some barite in it, the barite will stay in your sluice because it's heavy. This is a piece of gold and silver bearing quartz vein from Nevada, and it has on the right, I've circled with red, some calcite. There's some calcite included with the quartz. And then what I've circled in green, there's some kind of black rods there. That's tourmaline. It's a black tourmaline. And the formation of tourmaline in quartz veins usually indicates that the vein was formed at a bit higher temperatures.
Next, we're going to talk about finding a quartz vein. Now, how do you find quartz veins? Because, sometimes they stick out of the ground. They're pretty obvious. Other times, they're even with the ground and maybe covered with dirt. Sometimes, they're broken up and not so valuable. And one of the things that's important to be able to identify and recognize is what they call float quartz. And float quartz is just quartz that's broken off from a vein. As a hillside or mountainside weathers, the rock comes off, and usually at the surface, the quartz veins are fractured and broken. And so as the rock and hillside weathers, bits and chunks of loose quartz will, be weathered and rolled down the side of the hill. And so this type of stuff is called float quartz, and typically where you do have a quartz vein, you'll have a concentration of this pieces of float quartz. Now, there's different kinds of quartz. One of the things that identify float quartz is that it's jagged and sharp-edged and angular and that sort of thing. Whereas a lot of times gold that's been rolled around in a stream or a river, it'll be rounded and smooth and that kind of stuff. Completely different than the jagged edges of the float quartz. And a lot of times you'll have maybe up on the side of a hill some gravel that used to be in a stream. And so you'll be up there and you'll see some chunks of rounded quartz, but you got to know that that's from a gravel deposit. The rounded quartz comes from gravel, and the sharp-edged quartz comes from a vein. Now, why do you have quartz from, accumulating from veins and even the river quartz, staying? Most rocks will weather. So after being exposed to air and rain for thousands of years, they kind of break down and turn to clay and other, sand and things. But quartz has this quality of resisting the elements that attack it. It just doesn't dissolve. It doesn't change to something else. It doesn't weather away, like so many other minerals do. And so because it resists weathering, it's found on the surface. And even though you might find float quartz and the actual vein might be 50 or even 100 feet above you on the side of a hill, the float doesn't go anywhere. It doesn't disappear like other kinds of rocks will. And so you can trace the float back up to its source. And let's talk a little bit more about tracing, and let me show you some diagrams and talk about how to trace broken float quartz back to its source.
Now, when I talk about angular, sharp-edged float quartz, this is the kind of stuff I'm looking at, and this is the kind of stuff I'm talking about. You can see there's no rounding to this. It's all sharp and broken and that sort of thing. So this is what float quartz looks like. The alternative is stuff like this. There's a lot of pieces of white quartz in this picture, but every single one of them is rounded and tumbled and smooth. And so, this is stuff that's been in a river and gotten rolled around so much that it's all smooth. This is part of gravel. What you're really looking for is accumulations like this, where there's a whole bunch of pieces of angular, mineralized looking quartz all in the same area. And some of the rocks here that are brown and are in the picture are actually just real dirty forms of quartz just covered over with some dirt. But all this quartz is angular and sharp and indicates that it's come from nearby. Now, this is an accumulation near an actual known vein. I mean, it's a vein that was actually mined in the 1800s. But still, you have this natural accumulation of broken quartz near the vein. Now, here's a diagram that I did up for tracing gold up to a pocket source in a vein uphill, but it works just as well with tracing a quartz vein. With the gold, of course, you have to take pan samples and test each, do little holes and test each section as you're working your way up the side of the hill. But with quartz, you can actually kind of look on the ground and see the float quartz, and if there's more and more and more as you go uphill, you're indicating that you're getting close to the source. And the same thing too, decided where to turn uphill as you're going up a stream, and maybe you start seeing this angular float quartz, and you get to be more and more, and then eventually you kind of reach an end of it. Well, when you reach the end of it, you got to kind of turn around a little bit and go uphill. On one side or the other, it could be on either side of the stream. You just got to look for the float quartz and see which side it's on. That you trace it uphill, uphill, uphill until you get a high concentration of this angular quartz, and likely the vein is very near there, and you can start looking around. One of the downsides of hunting for quartz veins, though, is the thing that they can, and often, frequently, not always, but sometimes do get buried by soil. This is a road cut, so you see a cut through the ground, but below at the bottom there, that's a good 5 to 6 foot wide quartz vein. Something very obvious, you would think, but it's got 5 or 6 feet of soil on top of it, and so it's buried and no one can see it. Unless this road cut had been made right here, you would never know that this vein is here. And so sometimes, tracing quartz veins can be difficult in areas when they're covered with soil. You may only see just some of that float quartz down below on the side of the hill, but you may get up to the top and find no obvious concentration because it's buried.
Let's talk next about how quartz veins form. And I mentioned that they're often found in things that look like fractures or fault zones because, generally speaking, they form from hot water solutions that are deep in the earth. And so if there's a nearby hot rocks, molten rocks, that kind of thing. They form out of hot springs and stuff like that, where the water is heated, and actually hot water under pressure, because kept above the point of boiling water. But if you're down deep in the earth, that rock and the water is under pressure, and so you don't have any boiling because it's kept under pressure. It's like a pressure cooker, right? It's under pressure, and that superheated water that's under pressure will dissolve to a certain extent quartz out of other rocks, even out of other minerals. Minerals that have silica in it, that have quartz in it, but it's combined with iron or aluminum or other metal. Well, the hot water can dissolve the quartz out of those other minerals and then carry along with the hot water until it gets someplace else that's either cooler or nearer to the surface or something like that, where the water goes through these fractures or fault zones, breaks in the rock. The break in the rock provides the conduit for the water to flow in. And as it gets to cooler places or nearer to the surface, the silica, the quartz that's in the solution, will drop out. Now, if it has other minerals with it, maybe it has sulfides and things like that, or maybe gold, or maybe silver sulfide minerals, depending on the environment that it formed in, and what the sources of the hot water are, and what kind of rocks are nearby. All these different factors determine what kind of quartz vein and whether it's mineralized or just barren. You have to have the right chemistry to produce the mineralized quartz that we'll be looking for. Now, let me show you some examples of mineralized quartz and stuff that you can look for when you're out prospecting for quartz veins.
Now, I've already talked a little bit about mineralized quartz, and it's basically quartz that's either iron stained or has visible sulfides in it, or both. Frequently, examples may look like this, where they have lots of rusty coloration and maybe even pockmarks and things like that. Now, look at pieces like this closely, because you may see some visible gold, but even if you don't, it's likely that there's at least some gold here.
Now, I mentioned that other minerals can be found in quartz veins. We already talked about things like calcite and fluorite, but the valuable minerals, in addition to gold, that can be found with quartz veins include silver minerals, of course, but also various sulfides, pyrite, galena, sphalerite, various silver sulfides like perargyrite and that sort of thing. So let me take a look and show you some different minerals that are commonly found in quartz veins that are associated with gold and or silver, other minerals. It's really interesting. So let's take a look at that.
Often the quartz will have some visible pyrite in it. You may find chunks like this. Now, this is not gold. This is just iron pyrite in the quartz. Sometimes mineralized quartz may have other sulfides beyond pyrite. This gray material is a mixture of galena and sphalerite, which are lead and zinc ores, but then the white is quartz, and this is mineralized with both silver and gold. This is a piece of quartz vein material from Virginia City, from the Comstock lode, with black spots of silver sulfide. So yeah, there's high gold values in this rock too, but what you can see, the black spots, that's a silver sulfide, so it's rich in silver too. The silver sulfide mineral is known as acanthite or argentite. And this is a quartz vein with a sulfide mineral called tetrahedrite. That's the gray that you can see in the sample there. And it's partly oxidized when the tetrahedrite is a copper antimony sulfide that normally has significant silver in it. And when it oxidizes, because of the copper, you get this green malachite mineral that's on there. So that's what the green is. But it's a copper silver quartz with minor gold.
Now, I mentioned, of course, a couple of times before, but I'll say it again, the vast majority of quartz veins don't have significant values. Even one, like I say, that may be barren, and then there's one little spot that has good gold in it. You never know, because that one little spot might be 10 feet down, it might be 100 feet down. You never know, and it might never exist. You might drill 100 feet down and not find anything. It might not be there. It might be barren all the way along the whole length of the vein from start to finish. So how do you evaluate quartz veins? How do you take a look at them? Well, it takes sampling, and the easiest, simplest way of sampling is to crush the material yourself, crush it to like a fine sand size, and pan it out, pan it carefully, get like a 1 pound sample and crush it up and see what you got. See if you get any color. Do you have mineralized looking quartz vein material? Is there pyrite there? Is there other sulfides that would indicate maybe gold might be nearby? Maybe it is. So it's one of those things where you have to test and see. I get people telling me that, hey, I found a quartz vein. I'm rich, aren't I? In fact, I just got something from a cousin of mine who found some quartz and wanted to know if he'd struck it rich, and I told him no, probably not. But the only way to know is to test and see. If you've got a lot of quartz float laying around, something on your property or something, or someplace that you found, you might want to test some of that and see. The vast majority, like I tell you, is doesn't have it. One way to test a whole lot of quartz quickly is to do it with a metal detector. Now, if you have only little tiny dust-sized quartz or gold particles in it, you may have a lot of that, and it may be valuable ore, and you just test it with a metal detector. Metal detectors don't see dust-sized particles of gold. Usually, even the most sensitive metal detectors will only see down to a few thousandths of a gram, which is small, pretty darn small, too small to pick up with your fingers, but way bigger than a dust-sized particle. And even those tiny particles, when they do see them, they're only seeing them at short distances. They can't see deep, but if you have a bigger chunk, the metal detector will see farther. So the quickest, easiest is to go over with the metal detector. The next, like I say, is to crush and pan. And then the third way is to actually have assays done. And yeah, it's expensive to send off samples of quartz material and get back from a lab telling you, is there significant gold and silver in this rock? The lab will let you know. The crush and pan and the metal detector thing work well for gold, but they don't work really great for silver-bearing minerals, which most silver in veins is not metallic silver. It's silver combined with sulfides and other minerals, and so the metal detector just generally doesn't see those very well because it's the metal detector's looking for metal, right? And so if you don't have metallic silver, which is the case 99.9% of the time, it's not going to see it very well. So in those cases, you really do need the assay. And the other thing is to take a number of samples along the length of the vein. It's very common, even in a good vein, that parts of the vein will be, really low grade, almost barren, and other parts will be good. So, just because you take one sample, sometimes veins will go on for hundreds and hundreds of yards, and they may have good gold in some places and not so much in others. Now, I did a whole video about home assay testing, how to weigh your sample, do your crushing and panning, weigh the gold that you get out, assuming you get some, and then figure out what the grade of the material is, whether it's worthwhile or not. I did a whole video on that. I'm going to put a link above, and if you're interested in the technique and how to do that and how to figure out real numbers, take a look at that video because it has a lot of hints and information about evaluating quartz veins and that sort of thing. Now, if you do find something good, I had a friend of mine who did some panning and sampling and tracing like we talked about earlier and found a deposit, and he's been mining it, and I've actually done a couple of videos on it, and he's really had a really successful and produced a lot of ounces of gold. He's hit some really high grade rock. A lot of his rock runs more than 10 ounces per ton, which is pretty good. The vein, of course, is only about 6 inches wide, so it's not like you're getting tons and tons of 10-ounce gold. But still, even with a narrow vein like that, and one of the things about veins is on the surface they're likely to be fractured and broken, and you can probably dig them with a pick. But as you get down a little further, they'll harden up, the fracturing will be less because of weathering and stuff at the surface. The fracturing will be less when you get down, and the rock will be harder, and you may have to do something to break the rock. Initially maybe you can use some sort of chisel hammer type thing that can run off electricity, but eventually you're gonna have to break rock. And my friend who can't, there's laws concerning explosives, how you store them and that sort of thing. And so unless you are fully qualified for using and handling explosives, I don't recommend that. And what he has gone to is this expanding grout material that they use for breaking stuff. You can drill a hole like you would drill to blast. You fill this grout in there, and overnight it hardens up, sets up, and expands, and the expansion of the grout breaks the rock. So it's an interesting way of doing things, and that's what he uses to break the hard rock in his hole where he's getting this gold. He can't use explosives, like I say, the laws and other things, that's just not practical. But this kind of expanding grout stuff, you can get that through Home Depot. It does have some lye in it and some chemicals in it that you want to use gloves. But other than that, it's not really, certainly nowhere near as dangerous as real explosives. Now, finding and working, quartz veins, it can be very productive. Like I say, my friend has produced several pounds and pounds of gold from his find and his little vein that he's been working. And it can be really profitable and really beneficial, but it takes skill. You can't just have no idea what you're doing and go in and be successful. In order to impart to you some of those skills, understanding the geology, understanding how to work these veins, understanding how to extract the gold from them, I wrote a book. It's called Fistful of Gold, because that's what I want you to be able to go out and do, is get yourself some fistful of gold. And I think it'll be a great thing to you guys, and I'm going to tell you a little bit more about my book right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's, like I say, an encyclopedia. There's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold, because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount, I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at NevadaOutbackGems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video, you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done. And so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.